So today we'll discuss the scheme of a IA1, as all of you have already written the IA1, and you may be expecting some marks based on what you have written, and a lot of mistakes you have done in the IA1. I'll spend a little time to show you what all mistakes you have done in the IA1. Reason is you will not repeat that in the IA2, IA3 as well as in the main exam. That is the reason I would like to show all the mistakes done by you. And before going to the voltage shunt feedback amplifier, it is today's topic, but we will discuss the mistakes done by you. This is a summary. No polarity shown for a op-amp, no inverting, non-inverting terminal. For transistor, they have not mentioned NPN or PNP. Page numbers are not written properly on the pages. R1 and RF are not mentioned in the figure. Arrow mark and ground both look same. It is difficult to differentiate. There is no diagram. Directly the derivation has been started from few students they have started. I don't know how come it's possible. And scanning is not done properly. At the end of the eye, you are supposed to scan. Some of the pages are not at all visible. Some of the pages are orientation is entirely different. And instructions are not followed to give the file name. So now I'll go to the scheme. Then I'll show you the mistakes done by you. So give me a few seconds. Voltage shunt feedback amplifier. Note on the IN, IB, IF. Let us go to the next slide. So let us apply a KCL at node V2. IN equal to IF plus IB. Observe carefully here. I am talking. Hope all of you are getting. So incoming current equal to outgoing current. Now, see here. Is IB is more or IF is more? Type your answer in the chat box. Fast. Time is less for me also. According to you, whether IB is more or IF is more, that will be your attendance. Do it fast. Observe. See, this is a total incoming current. Outgoing currents are two. One is the IF and there is a IB. Which will be more? Whether IF will be more or IB will be more. Anyone you type it. It may be wrong also. I will be happy to see what you are typing. So IB is more. Okay. Somebody is saying IB is more. Is IB is more or IF is more is a question. Many have typed IB is more. Abhinandan has typed IF is more. Thank you, Abhinandan. I like you because all the answers were IB, but you dared to say IF. I sincerely appreciate your answer. And many students now they are typing Kirti, Sneha, IF. Have a common sense because all of us know already input resistance of the op-amp is very, very high, ideally speaking infinity. Hence, as Ri is very large, IB is very small. Therefore, IF will be equal to almost IN. Hence, I can write IN equal to the voltage, these two difference divided by R1. That is nothing but a Vin minus V2 by R1. Similarly, I can write a V2 V0 divided by RF. So, these are the two equations I can write down. And we know that V1 minus V2 equal to V0 by A, or V0 equal to A into V1 minus V2. You have a 1 minute time, copy down. Not 2 minutes, only 1 minute you have. Hardly you are supposed to copy down 3 to 4 lines. This diagram is with you already. 3 or 4 lines you have to write down in your notebook. And parallelly you try to understand. IN equal to IF because IB is less. Why IB is less? Because RI is very large. So IN you can say almost equal to IF. Hope most of you have copied. Only 3 lines you have to copy. IN is almost equal to IF. IN is given by voltage difference Vin minus V2 divided by resistance R1. Similarly, V2 minus V0 divided by RF. And we know that V1 minus VT equal to V0 by A. So I'll give another 2-3 seconds. Then we'll go to the next slide. Okay. We know that V1 minus VT equal to V0 by A. It is from the previous slide. V1 equal to 0. Why V1 equal to 0? Observe here. Hey, see here. V1 is grounded. Hence V1 equal to 0. Therefore, V2 becomes now what? Minus V0 by A from this equation. And this V2 equal to minus V0 A, I am going to fill in the previous Vn minus V2 by R1 equal to V2 minus V0 by RF. In this V2 equal to I am going to fill, I am going to rewrite the equation and I am simplifying, that's all. So please copy down these 2 lines fast. Nothing I have done. Simply I have copied V2 value here, another V2 value I have copied here, and I have multiplied this side R1 RF, this side I will get RF and this side I will get R1, that's all, and I have rewritten, and I have multiplied inside RF Vin plus RF V0 by A. Similarly I have multiplied this inside minus R1 V0 by A minus R1 into V0. So you can take a maximum another 30 to 40 seconds and copy down these 4 lines. What you have done? V1 equal to 0, hence V2 will become minus V0 by A. And this V2 equal to minus V0 by A, we have substituted in Vin minus V2 by R1 equal to V2 minus V0 by RF. In this we have substituted. Just we have simplified 2 steps. Take another few seconds and try to understand. So I'll wait for another 5 to 6 seconds. Later this video will be available in the YouTube. We can do the revision. Let us go to the next slide. And remember, whenever I am writing a line, above that is from the previous slide, is there in your notebook. Steps are very simple. All V0 I am taking one side, so that it will be easy. Then divide by A is there. Simply I will multiply A, so that I will simplify the equation. And remember, A when I multiply A get cancelled, but here there is no A I got extra. And now what I am doing, a V0 is common, I am taking V0 common. And now last step what I am doing, V0 by Vn equal to I am writing. Nothing else, V0 by Vn equal to Vn I will take this side, and therefore minus A RF whole divided by whatever is there, this will come, and this is called as the exact equation. So the negative sign indicates input and output signals are out of phase by 180 degree. You have 1 minute, you can copy down. What you have done? You have taken the same equation from the previous slide and simply V0 we have took this side, so that, or you can say these two I am taking this side, RF Vn I am taking this side, all V0 we are taking one side, that's all. And later V0 common I am taking, and then I am writing V0 by Vn equal to, that's all. But here I will get a negative sign that indicates there is a phase shift. You have another 15 seconds, you can copy down. Let us go to the next slide. V0 by Vn, the same thing I had taken from the previous slide, and since R1 is very high compared to R1 plus RF. Why? Because A is very high. Very high into R1 definitely will be greater than R1 plus RF. So therefore I am writing minus ARF divided by AR1. A get cancelled. I got a minus RF by R1. Gain of the amplifier is set by R1 and RF. The gain can be set even to the less than 1. This is very important. Now you have 35 seconds. You can copy it on 2 lines. AR1 value is very high compared to R1 plus RF. Reason is A is very high. And A get cancelled. I'll get a minus RF by R1. It is called as the ideal. And gain of the amplifier can be set choosing R1 and RF. One interesting point we have to remember is the gain can be set to less than 1 also by choosing a proper RF and R1. Let us go to the next. Now the same equation I have taken to write AF in terms of A. What we are doing? Numerator and denominator we are dividing by R1 plus RF. And A RF by R1 plus RF is nothing but a K. A into K divided by 1 plus A. B is nothing but R1 by R1 plus RF. So just take a 1 minute or few seconds to copy down. To write AF in terms of A, divide the numerator and denominator by R1 plus RF. You got A into K by 1 plus AB. K is RF by R1 plus RF. B is R1 divided by R1 plus RF. Don't interchange. In the exam, remember B is R1 divided by, K is RF divided by. Denominator is same, R1 plus RF. Only 2 lines you are supposed to copy. AF equal to and K equal to and B equal to. Take another 10 seconds. Then we will go to the next slide. So let us go to the next slide. The one line block diagram of an inverting amplifier, how we can write. And these things you people are studying in depth in your control engineering. So it is in series, it is a multiplication K, and it is a feedback, you will get A by 1 plus AB into K. So these things you have studied or may study in depth in the control engineering. And we teachers, it is difficult for us to correlate how the control will come into picture in LIC, how the LIC will come in the subject of control engineering. We talk about the stability in the control engineering. Actually here also we can talk, but it is not in the syllabus. I'll give a little hint and you should able to correlate what control engineering teacher used to teach, what the LIC teacher is using to say, and he used to say instability in LIC. In control engineering he is also talking about stability. You should be able to correlate, you should be able to understand those. Now let us go to the next slide. Hope most of you copied. It's hardly a 1 line diagram. So ideal closed loop gain. Just read it. It is there in your notebook. No need to copy. If you want revision, you can write AF equal to AK by AB. Or you can write a minus RF by R1. It will become a practice when you write twice or thrice. Take another 6 seconds. Don't copy everything. Why AB? Because 1 plus AB equal to AB. Because AB is very high compared to 1. So it comes nearly AB. That's the reason we are writing. In simple format, how we can get RF by R1. So virtual ground is very important concept one should understand, and we know V1 equal to V2 always, because op amp gain is infinity, hence we say V1 is always equal to V2. This is one concept, virtual ground. When I say V1 is now grounded, because see V1 is grounded, then V2 is approximately equal to V1. In our discussion whole derivation in this subject you have to remember. And V2 is approximately at the ground because both should be equal nearly. Inverting terminal is said to be virtual. Sir, when I can say this is a virtual ground, sir? When this is ground, it should be equal to, Vt should be equal to V1, hence I can say Vt is almost near to the ground. We cannot say it's a ground, we can say it's a virtual ground because V1 should be equal to V2. This is one important line which you have to remember. This concept is used for so many circuits. When you are analyzing this particular concept, we use it. You can take a 30 seconds to read it and understand. Remember, V2 is approximately equal to V1. Now in this case, V1 is grounded. And inverting terminal is said to be virtual ground. Reason is non-inverting terminal is ground. I cannot say V2 is ground. I can say virtual ground because V2 should be equal to V1. So let us go to this is one concept which you have to remember. One example we will take. So in this, IN is almost equal to IF. We have already discussed because IB is less. Why IB is less? Again we have discussed. Input resistance is very high. That is the equation you can write. Again how I can write IN equal to V by R, Vin minus V2 by R, Vin minus V2 by R, and this side V2 minus V0 by RF. These are the currents. However, V1 and V2 are 0. We have discussed already. Why? V2 is ground, V1 is ground, V2 is virtual ground. Therefore, I can write directly the Vin by R1 equal to minus V0 by RF, and rearranging I can say AF equal to minus RF by R1. See, whatever the virtual ground concept you have used, because of that, within a 2 steps we got the same equation what we have derived previously. Take a 20 seconds and observe this carefully, or even you can copy down also, 2 lines hardly. V1 V2 equal to 0 and IN equal to IF, IN equal to equation I have written, IF equal to equation I have written. Simply I have filled V1 V2 equal to 0, I simplified, I got AF equal to minus RF by R1. Let us go to the next. Diagram is saying, now input resistance with feedback, this you are supposed to copy down. Take 1 minute, write down neat diagram. Easiest method to find the input resistance is to millerize the feedback resistor RF. How to millerize? Directly I take RF by 1 plus A, this side also RF into A by 1 plus A. We will not discuss how, why, etc. As of now, to find the input resistance, you have to millerize the feedback resistor and equivalent resistance will become like this. Then we will do the derivation for input resistance with feedback. So note down properly. Vin, A into VID, RI, V1, V2, VID. So this diagram will be visible to you people in the next slide also. The input resistance, how I can write. We will not talk about output now, only we will talk about the input. RIF equal to, observe this is the RIF. Hey, see here, this is the RIF. I am seeing from this side. So this RI and RF by 1 plus A will become a parallel, and that resultant will become a series with the R1. That is the equation what you have written, RIF equal. This is the exact. And since RI and A are very large, when I say A is very very large, RI is also very large. Since RI and A are very large, this will come around 0 parallel with something, it will come around 0 only. So therefore I can write RIF equal to R1. Take a 30 seconds and copy down this. Since Ri and A are very large, Rf by 1 plus A becomes almost 0. 0 parallel with something will become 0. Hence, RIF will become equal to R1. Diagram is with you. Hardly note down. RIF equal to R1, this is ideal what we get. We'll take another 2 minutes and we'll try to wind up. Output resistance, it is same as non-inverting amplifier because R0 is very small and equation you have derived for R0F. So R0F equal to R0 by 1 plus AB. So seeing at the output side, we have not changed anything. Hence, the equation will remain same. R0F equal to R0 by 1 plus AB. You can observe the circuit diagram, output side we are keeping everything same. Hence, equation will remain same. Hence, R0F equal to R0 by 1 plus AB. All of you know R0 is what? R0F is with feedback. A is what? B is what? Everything is already copied many times. Let us go to the next slide. So bandwidth with feedback, and we have already discussed for a previous case. F equal to F0 to duplicate 1 plus AB. For mu741 we have discussed. I think time is almost over. This we'll try to cover in the next class. And now, if you have any doubts, I'll be here for another 2-3 minutes. You can ask me.